Today in this video, we're going to do the whole Unit 9 review, which is basically over the topic of rationals. So for our first question, we're going to go back to radical functions. So, radical functions. So our first example is going to be g of n is equal to 5 negative n minus 2 over 2. Now, this doesn't seem to have a lot of ink, so I'm going to go ahead and swap it out. Alright, so now what we could do here is that, this is the inverse of radical functions actually. We're not solving for rational functions. This is an inverse. So we can replace this with y and the other with x. Now, when we're doing that, we can actually, in order to find this inverse of the function, you have to swap y and x. And when you swap y and x, you get x is equal to the fifth root of negative y minus 2 over 2. So now that we got that, we could solve the rest for y. So we can, this is basically, we could, this is, maybe write it better, because that's not true. It's not just on the top. So in order to solve that, we have to fifth them, I guess, to get rid of the radical, because this is basically equal to 1/5. This whole radical, and when you multiply it by 5, because when you distribute, it just multiplies by 5. Remember that? If you distribute something that's being distributed to an exponent, it's basically multiplying it. So once you do that, that's just equal to 1/1. So that's 1/1. So that's basically equal to eliminated radical. Okay. So once you do that, you get rid of the radical. Hold on. You get rid of the radical, and you get x is equal to negative y minus 2 over 2. So once you have that, you're going to have to multiply both sides by 2. Oh, and remember this is basically doing that, so you have to multiply this by 2. And that gives you 2x. 2x to the fifth, remember that. Because remember, I had to multiply that by 5th, whatever you're doing on the other side, you have to do the other. 2x to the 5th, once you do that, so when you multiply this by that, it's basically like this. Those two cancel out. So all you have left is negative y minus 2. Plus 2, 2x to the 5th plus 2 is equal to negative y. Divided by negative 1, divided by negative 1. Then your answer is negative 2 x to the 5th minus 2. That is your inverse function. But wait, you are not done. You actually, after that, you have to set it to the g of x, how it was originally in the problem, how g of it. So you have to replace the variables to what they actually were at the beginning. So now that you have that, switch it back. So now it is g of n is equal to negative 2 n 5th minus 2. And that is your solution. Okay. Pretty basic, huh? Okay, let's do another ball. This is not a very good eraser. We could do let's do something that has the opposite. So instead of square rooting it, instead of cubing it or fifthing it, you square root it or fifth it to the fifth root. So we have Fn is equal to n plus 1 to the fifth minus 2. So in order to solve that, we already swap these two with the x and y. Then swap them. Now you can solve for y. So, I mean, what you can do first, get rid of the 2. It's kind of difficult if you just square root the fifth of all of this. And that's basically hard to do. So you get x plus 2, you get y plus 1 to the fifth root. So we all fifth root it because this is basically saying 1/5 times fifth. It's gonna be shit. Times fifth. Right? Okay. Once you do that, that's equal to 5/5, and that's just equal to 1/1. Okay? So once you do that, you have to do that to the other side. What? Minus 1. That's your answer. Leave that up to the radical because you did that up to the fact you put it to the fifth root. Okay. So remember you have to put it back into these terms. So what you do is you do f of n is equal to the fifth root of n plus 2 minus 5. And that is your solution. That is your inverse. It's basically like that the whole time. I mean, it's pretty basic. I don't think I have to review over it that much. Okay. So which one to go over? We can go over this one and call it a day for the inverse of functions. Then we go to the next topic. Gotta be real careful, this whiteboard falls easily. Okay. So we have g of n is equal to negative fifth root of n minus 3. So we don't want the fifth root, the whole thing over here. Oh, and first remember swap. You change it to x and y, swap them. So, and just to do it straight in my mind, I'm just gonna do x is equal to negative y. Okay, just did that real real quickly in our mind. It's already got steps I've taken to get to that step. Okay, so we plus the 3, x plus 3 is negative with y. So we don't want to handle with the negative whenever we do this. It's annoying. So what we're gonna do, actually not gonna do that. What we're gonna do to get rid of the negative, you actually have to divide it by a negative. Negative divided by negative is equal to positive, right? So once you do that, this turns to negative x minus 3 is equal to 5th root of y. So fifth it, because it's 1/5 times 5th, it's equal to a whole. That means negative x minus 3 to the 5th is equal to y. That is a solution, but remember you have to put it in terms of g of n and n. So once you do that, your answer is g of n is equal to negative n minus 3 to the 5th. Once you get that, that's the solution. Yeah. Simple as that. Let's see. Yeah, we're done with the inverses now. Be real careful with this whiteboard. It's all at any moment. Serious one? Keep hearing Siri something. Keep hearing something in my phone, but whatever. So, next one. Solving the equation of radical functions. So, what we do here is that we actually try to solve for it depending on what we get. So let's put this here. Okay. So what we do, let's do a real easy one, quick. Let's do it real quick. So we got the square root of 5x plus 1 is equal to 6. So we already know we multiply this by 2. Remember, this is just 1/2. Multiply by 2 makes it. I think you get it by now. Do that. 36 is equal to 5x plus 1 minus 1 minus 1. 35 is equal to 5x. 5, 7 is equal to x. That's the solution. Easy as that. Now, let's do a more complicated one. This one's going to take more work. That's for sure. So, our next one is going to be, let's do that one. Yeah, this is G. So, what we have is the square root of 44 minus 2x is equal to x minus 10. So what the problem here is we can add to the 10 to the other side, but that doesn't really solve the situation. Actually, what we do first, yeah. That just makes it harder for yourself because no matter what you do, you still gonna be a struggle. So what we do is we square this part and we square this part. That gets rid of the radical, and that becomes x minus 10. X squared. Remember, you have to do the floating method. There's more than one term on the outside. Outside the radical. X squared minus 10x minus 10x plus 100. Okay, so we have x squared minus 20x plus 100 is equal to 44 minus 2x. So what we could do here is that we can make this set equal to 0 because it looks like a standard form equation right here. So let's just move all this so that one side set equal to 0. We should be able to use it by using factoring rules. Okay. So what we do is add 2x. That equals negative 18 x plus 100 x squared is equal to 44. Subtract 44, subtract 44, that's equal to 56. So once we have that, so we already have it set equal to 0, okay? So now we use the simple factoring rules. What adds to 56? What multiplies? What multiplies to 56 but adds to negative 18? Negative 14 and negative 4. So we can simplify that. X minus 14, x plus 14. Oh. So now that you have a factor, you actually set it equal to 0. That's just basically means you take the opposite of what you got in here. So you have x is equal to 14 and x is equal to 4. So before you do anything, check if it actually works. So if you plug in negative 2 times 14 is negative 28. 44 minus 28 is that. I don't know. Let me check that real quick. Sorry. So we plug in 14 for x. That's what I'm basically doing, so that we can see if it actually works and they function. So we do 2 times 14 is equal to 28. 44 minus 28. 44 minus 28. Is 16. Square root of 16 is 4. 14 minus 10 is what? 4. So 14 works. Now let's try 4. Negative 2 times 4 is negative 8. Negative 44 minus 8. 44 minus 8 is 36. 36 squared is 6. What is 4 minus 10? That's negative 6. So that won't work. Negative 4 is extraneous. That means your only solution for this function is 14. Alright, so now that we have that, let's do another one. Let's see. Versatile. Alright. These take some time. But you would be able to, it is solvable. So, we have square root of 3x minus 8 plus 1 is equal to square root of x plus 5. So, Once we have that, you know, if you move this to the other side, it doesn't really change the situation which you're in. So, the only thing you can do is square them both. These are both square roots. That cancels that square root. Okay, here, we don't do it second. Since these are both a radical and an outside term, you FOIL. So we have 3x minus 8 plus 1 times square root of 3x minus 8 plus 1. Once you do that, that times that, radical times a radical is equal to a whole. So you get 3x minus 8 3x minus 8 plus 3x minus 8 square root. So it was multiplied by another. And then we get plus square root of 3x minus 8 plus 1. So, what we have here is two radicals. They could basically add it together because they both have an invisible 1. So you get 2 square root of 3x minus 8. And we can add this 1 to here. So, plus 3x minus 7 is equal to x plus 5. Remember that. That's still up there. So once we have that, let me erase all this so we can have more room. We can start solving. X plus 5. So what we can do is that we can move all the terms over here and just divide it by 2 and square it to get rid of the radical. Okay? So we subtract 3x. That just gives us negative 2x plus 5. Oh, let's just add the 7 also at the same time. So 5 plus 7 is 12. Is equal to 2 square root of 3x minus 8 divided by 2 divided by 2. That gets you negative x plus 6 is equal to 3x minus 8 squared. Square root. Okay. Now we can just square. Well, I get rid of the radical there, but since this has more than one term, I'm sorry, but you're gonna have to do the FOIL method. That's why this problem takes so long. It's a bunch of FOIL methods. So we have negative x plus 6 times negative x plus 6. Yeah, because x squared positive because 9 times negative is a positive. So divide itself, multiplied by itself. They both have. So when they multiply by themselves, they have the same base, so the exponents add. So when you do negative x times 6 is negative 6x. Minus 6x plus 36. So you get x squared minus 6x, minus 12x actually, because these two negative 12, negative 6 adds together, plus 36 is equal to 3x minus 8. So don't forget that you still have those there. So you can add 8, and subtract 3x. So it goes negative 15x, x squared is equal to 0. 36 minus 8. I'm sorry, I'm not really good at calculations like that. 28. Plus. Oh. What? 44. So, we have that here now. So, what we want to do is actually what multiplies to 44 by asking negative 15? Negative 11 and negative 4. Okay? So, and we know our solutions are x is equal to 11, x is equal to 4. But we got to check it. See if it's true. So in order to check it, let's put back the old equation. The original equation. Just plug it into the original equation and see if it works. If both of them work. One might be extraneous, one may not. Okay, so let's plug in 11. 33 minus 8. Now what is that? 25. 5. So I times the 5. Square root of 25 is 5. 5 plus 1 is 6. So the left side is 6. What's 11 plus 5? Oh, 11 plus 5 is 16. 16 is 4. Okay. That does not work. X equal to 11 does not work. So let's plug in 4. 3 times 4 is 12. 12 minus 4 is 4 times 3 is 12. 4 times 3 is 12. Minus 8. Whoa. Oh, 4, yeah. 4. Square root of 4 is 2. 2 plus 1 is 3. What's 4 plus 5? 9 is 3 also. So, 4 is your only solution. So, we've gone pretty far so far. I also got another one. Let's deal with fractional exponents actually. Let's do this one. Then we'll do inequalities. And then all the other simpler stuff. This stuff is simple. And transformations. Identify transformations and the functions. So what we got here is 5 minus x 1/2 minus 2x is equal to 0. Add a 2x, add a 2x. That is 2x is equal to 5 minus x 1/2. So, in order to get rid of that 1/2, I'm going to have to square it, because that's basically 2 times 1/2 is 2 over 2. And that's a good one. So, you can square this also. And remember when you do that, this distributes to both the 2 and the x. So, 2 squared is 4, x squared is equal to 5 minus x. So now we can add the x and subtract the 5. So we get 4x squared plus x minus 5. It's equal to 0. So now let's do the snowflake method. 4 times negative 5, negative 20, divided by what is multiplied by So what multiplies to negative 20 but adds to 1? 5 and negative 4. Right? 5 times negative 4. Yeah. So that simplifies just to 5 over 4. That simplifies to negative 1. So once you do that, you get 4x plus 5 and x minus 1. So the two solutions are x is equal to 1 and or x is negative 5 divided by 4. So how do you know which one works? Let's do some calculations. Now the fraction's gonna be the one that's gonna be a pain to multiply. Divide by all the terms that are within. So 5 minus negative 5/4 square root minus 2x is equal to 0. So, excuse me. So, I just simplifies to plus because it's two negatives. So once you do that, you have to make this. You have to have the same denominator. So what you do is multiply this by 4. So you do 20 over 4 plus 5 over 4. That gives you 25 over 4. And when you square root that, because that's what basically 1/2 as a fractional exponent is, because this goes to the top, right, and then that one goes next. Okay. That's 5 over 2. Minus 2 times negative 5/4 multiplied by the top, negative 10 wait yeah positive 10 plus 10 over 4. I can already tell it's not going to be true, so that means that one's not going to work. But if you plug it in a 1, yeah, and a 1 in here, let's see if it works. 5 plus 1, 6, right? Oh, 5 minus 1. Sorry, I forgot to change that. I was like, that doesn't make sense. 5 minus 1 is 4. 4 squared is 2. 2 minus 2 is 0. That is your only solution. Okay. So that kind of concludes our fractional exponent. That concludes our part 1. We're gonna have like I don't know how many parts we're gonna have, but I'm just trying to take some breaks in between videos because I'm gonna try to post all these today so that everyone could review who works in my school to get ready for it. Yeah, that's just part 1, and I'll see you in the next video later posted today. Thank you.